Okay. So I just want to make sure that, can you hear me? Is it okay, Patrick? Okay. So yes, my name is Tomasz. I'm a lead cloud architect at Mindbox. Mindbox is a company which provides we provide environments based on container, specifically on OpenShift. And today, here with me today is David. David, can you introduce yourself?
Yeah, hello everybody. My name is David. I'm IT architect, as Patrick also mentioned before, from the BZWBK. I was responsible for implementation on the technology level of the OpenShift in our own organization, and I hope you will have some good time with us, Tomek.
Yeah, I'm pretty sure you will. So today, in our webinar, we would like to show you some examples of how we've managed to implement OpenShift within regulated environments, which is in BZWBK, which is a part of Santander Group. And we, as a company, we helped David and his team in bank to introduce and to implement OpenShift. So let me start with simple question: Why? Why did bank decide to implement containers? Actually, so many people think that containers are something really new and applicable only to small environments, such as startups, or only for testing or development purposes. Not something that you would put in a bank environment, because people think that financial institutions such as bank is very choose its solution to be very stable, not as modern as OpenShift, which obviously is. So in this presentation, I'm going to show you some examples of how we implemented delivering pipelines for applications, how we solve some problems with traffic filtering, or solve some unexpected issues that we discovered after security scanning. David will tell you more about how we managed. Well, actually, David and his team, how they managed to create secure container images, and we will start also with something that we called Road to OpenShift. So this is a picture. Actually, it was taken by me. It was taken by me near Dev Valley this year. So we went there to San Francisco to give a similar presentation at Red Hat Summit. And this road looks pretty nice, I guess. But just like this road, it isn't quite straight. There are some sharp turns. There are some bumpy parts, and David will tell you something more about how did bank decided, and why they decided to go with OpenShift and containers. So, David.
Yeah, exactly. Thank you, Tomek. As with any project in a big company, it's not that easy. And as you can see on this picture of the road to the OpenShift, it's straight on the beginning, but then somewhere about the horizon, there are some curves, etc. So it isn't always such an easy way to do anything. But also, I would like to tell you some few words about why we decided to show you the presentation, not why we decided to implement OpenShift, because this will be on the next slides, but why we decided to tell you about it. Well, to be honest, it was a lot of fun to cooperate with the Mindbox with this project. It was a lot of fun to learn new things and to observe how people in an organization are starting and learning to work a different way because the containers required such a really big change in how we really work. So let me tell you a few words about how bank looked like before containers. Okay, to be honest, we still look like this in some part, right? Because the OpenShift haven't changed the whole organization. It started some greenfield parallel to the, I would say, classic IT. So before containers, before this project we will be talking about, the bank had a lot of PCs on the virtual machines with Linux, Windows, etc. We had a lot of IBM virtual machine also. We had because of this a lot of technology obsolescence, because as you may imagine, when we provide just virtual machines and we give them to our administrators, it's really hard to manage in the big organization when you have a lot of people working on these machines. So we had a lot of manual work. We had almost no control over development components because when you again have a lot of people working on a lot of components, a lot of projects, you may a little to give you a picture of how big organization we are. We have about, to be honest, I'm not really sure, but about 300 or 400 people in IT without the development, just the administrators and this part of the IT. So it's really big organization. So we had also a lot of different versions of platforms, different, let's say, Linux, Red Hat, SUSE Linux, Windows, IX, IBM I, etc. Each in different version, different patch version, major, minor, etc. So a lot of different platforms are stated. So shortly, compliance and security are pain, really a pain to manage a lot of these components. So one day, a team I am a part of, we are the architecture team in the BZWBK. We have realized we need to find some, let's say, we need to take a bit closer to the Docker components to find out what Docker is, how it works, how we can use it, and how it can help our organization. And we have realized that we have a POC, proof of concept, within our organization about the Docker Swarm architecture. Furthermore, we also had the new business front-end project. So it was a part of our business initiatives, which required to create a new business application. We had also the POC in the architecture for the Docker Swarm, the one I told you we have realized we need to do. And we also had, and it was the biggest, to be honest, the biggest fun for us was to find that we have a Docker in production already in our online banking platform. So we had this frontend to zero project, which was a business project for a new front-end application for our branches. We had few POCs and we had pure Docker containers, Docker engines in production. Then we have found out, okay, so we should go together, because if we have just the POC, then POC itself is not enough for such organization as ours to prove that the technology is okay for us. So we have talked with the business owner of the Frontend to Zero project, and we have told them that, okay, if you will decide to go to the Docker platform, then you will be able to provide your application, to make changes in your application far much faster than you were used to do that in the old IT way. And they then decided, okay, let's try it. We had a little time for this, so okay, let's try it. So the short decision was, okay, we're going together, business and IT, not IT only, but also with the business application. because we had a POC for the Docker Swarm, so our first platform for this business application was to use the Docker Swarm. We have bought the commercial license, but a lot of issues arrived. We had issues with stability. As far as I remember, we had to reinstall our whole cluster 3 times. You should also realize that this POC was about 2 years ago. So I believe a lot of changed. And as far as I remember, the Docker decided to go with the Kubernetes, but I think it could be because of these issues also. So we had a lot of issues. And then because our business partner, the front-end tool owner, said, okay, guys, I really enjoy your making POC. I really like this technology, but it's not stable, and I have my business goals, so we need to do something. So the short point was, okay, let's send an RFI and RFP for the market. Let's ask what are possible technologies and what we can choose from. So this was done, and then after some really short, because it took us 2 months, as I guess, as I remember, sorry, we have realized OpenShift should be a platform for us, and this was also the point in the time when we have chosen the Mindbox as our partner for this project. So that's how OpenShift appeared in the our organization. Then, after the budget was ready, the money was prepared. Both companies, Mindbox and BZWBK, were prepared to start the project. We had to make some first assumptions for a project to make infrastructure design for our infrastructure. So it was funny because I will show you few decisions we have made, and what mistakes based on these decisions we have made also. First is, Bank for a lot of years before had the central repository for all of its artifacts. This was the Artifactory, and we have decided, okay, so we have the Artifactory, we have all of our binary resources inside. We make deployments from there. So let's use it also as a Docker registry because it is built into Artifactory. And let's don't use the internal Docker registry from the OpenShift. And to be honest, that was one of the biggest mistakes. Because why? Well, first, we have realized that it stops our developers from using the platform, because when you install the OpenShift and you install it by default, so with the internal Docker registry, then creating a project and starting your application on the OpenShift is really few clicks away from you. But when you disable the internal repository, then you need to make an integration. Then you need to create an account in Artifactory for every developer. You need to assign the project with this external repository. A lot of manual, okay, maybe not really manual because it's possible to automate this, but we hadn't time for this. And another thing was that Red Hat support in one time in the project said us, no, it's not supported. You can of course do that, but if something will fail, we won't be able to support you. So shortly after we made this decision, we made this architecture, we reorganized this architecture and started using the internal Docker registry because it really works far much better than what we had in mind before. Another thing is, as you know, we are the financial institution. Some of you probably keep your private money in our bank. So we need to be sure that your money is secure. How to say your money is secure? Well, it means that our applications are secure. It means that traffic between our applications is secure by default. So what we have said, okay, let's make the IPSec under the OpenShift. So doesn't matter what OpenShift has built in. Let's make the IPSec. Okay, so we have made the IPSec. it also was a lot of problems. The problems first arrived when we wanted to make an update of the OpenShift to the newest version, because the automatic scripts provided by the Red Hat, they do not keep in mind that there is an IPSec below your OpenShift. So it also make us that it also caused a lot of troubles with this. So another point was that one of our team members, by reading documentation, can you imagine someone was reading documentation, found that in the OpenShift there is a functionality called service serving certificate secrets. This is a functionality that for each created pod in OpenShift creates a pair of the TLS certificates, the private and public key. And if you create your images a proper way, then they will use it, and then they will publish only interfaces secured by the SSL. So this was also one of our biggest mistakes on the beginning of the project, that we haven't read the documentation truly. And now we are not using the IPsec below our clusters. We are using only the service serving certificate secrets. That was really also very big change for updating the cluster. Now it's smooth. Before it was a pain also. Another thing was that we have decided as a bank again, and having experience in the old technologies, that we need 4 clusters. We need 2 production clusters and 2 test clusters. Why 2 production and why 2 test? Because in bank we have 2 different types of applications. We have applications that are hosted only internally, so only for workers inside the company, like applications, front-end application, which is used when you come to the branch of the bank and you want to, I don't know, get your money or have a credit or something like this. Then a person from a bank worker, is handling your request in internal application, internal front-end application. And we also have another type of applications like our online banking, which is available in the internet, right? So we have a demilitarized zone and the internal zone. So we have found, okay, so we need 2 production clusters. One will be in the militarized zone, the second one will be internal, and we also need to have 2 test clusters, right, for the DMZ and for the internal traffic. Shortly after, we have decided, okay, but it's expensive. So the first improvement, and really simple, was that okay, we have an OpenShift, we have Docker containers, and what they give us is that we have a container. So it doesn't really matter whether I test it on this cluster, on that cluster, on another cluster. So maybe we can have just one test cluster. And that was the first decision which we have taken based on this bigger infrastructure. We wanted to have 2 production for the demilitarized zone and the internal zone, and 1 internal test cluster. But that's not the all. Also, we have realized that if we'll use some nice mechanism that are built into the next version of the OpenShift, remember we are 2 years behind at the moment, we can have 1 production cluster and 1 test cluster. Why 1 production? Because OpenShift in the version, when we were starting the project, we had the OpenShift 3.6. Now we are on 3.9, and there are some few functionalities that are
I will be
allowing
talking
us
about
to
them.
yes, exactly, that are allowing us to separate traffic, and this is something that Tomek will tell you more about. So I hope that in few words, at the moment I provided to you with a background of what we were doing in a time, why we have went to the conclusion that we need a new platform, why it was OpenShift, and what the first and a little bit big mistakes we have made and how we fix these mistakes. And now I believe Tomek will tell you some few words about another topic.
Yeah. So the one of the big topics that we covered, that we worked on during the project, was to create a new way to deploy containers to OpenShift cluster, or actually clusters. So of course, we use some kind of pipelines, and OpenShift has tight integration with Jenkins. So our work was to create continuous integration and continuous deployment pipelines in a new way that that is applicable for containers. Because actually, all of the guys who work on some applications knew that they needed to have some CI/CD processes, but this is something new that needed adjustment, that needed a new approach, and we had many discussions around this topic, but we soon realized that we need some goal, and we came up with this simple goal that we want to be able to deploy application in 10 minutes. So it's quite ambitious, I guess, goal.
Sorry,
and
please only remember that an application is not a one component. It's not one jar file or something like this. It's complex, a lot of these applications, a lot of jar files, let's say, right?
Yeah. So this is actually a screenshot from Jenkins pipeline from Blue Ocean interface, and the issue that we encountered was that in OpenShift, in this integrated Jenkins version, you're using OpenShift accounts to log into Jenkins, and Jenkins automatically creates roles inside its configuration, but there are only 3 roles available. So some someone who can view only, someone who can view your configuration, someone who can edit, and someone who can be actually an administrator of Jenkins. So that wasn't enough. And in this pipeline, we wanted to have an approval step, and we want to have only a defined list of people that were allowed to approve a pipeline to go to next stage. And these 3 roles were inflexible for us, and we decided to, because of this inflexibility, we decided to integrate Jenkins directly with with Bank's Active Directory. So that was something that we had to change in default Jenkins configuration. But beside this configuration, all of the Jenkins configuration is kept in infrastructure as code style. So we didn't touch many elements of it besides this Active Directory integration. And this is our initial design for a pipeline. So during our discussions on CD pipeline topic, we came up with this initial plan to build a multi-stage pipeline defined in Jenkins, of course, in a Jenkins file, kept in Git repository, version. So we had many steps, including building application, building container image, performing some tests on a dedicated environment, then some actually releasing security scanning and releasing application, putting container image inside Artifactory. As David mentioned, it was our first choice to put all container images inside Artifactory, and we decided it was our first approach. Of course, there were some notifications integrations with Jira, and next steps leading to deployment to next environments such as test, staging. This is sample names, test, staging, and production. As you can see, all these steps were performed on non-production cluster. So building and testing were done on non-production cluster, and only deployment to production was actually was to provide application and configuration on, well, deployment them on a dedicated production cluster. So this was all done from this Jenkins running on this non-production cluster. Okay, so that was our initial plan, but it changed on the way. It changed as we discussed further, and well, actually, bank's team had many internal discussions, and we came up with a separate pipeline, not for delivering, but rather for releasing application. And as David mentioned, application in this case was a bunch of, well, a set of microservices, and this pipeline, this dedicated pipeline, was created to test whole set of multiple microservices, perform some smoke test or some manual test if required, and then to leave decision whether to release such application, whether release such a set of container images, or just abandon them and go with next, test another release to fix some issues that were discovered during the test phase. And of course, we had a dedicated development environment that, thanks to image streams and triggers set on this deployment objects, we were able to provide a bleeding edge environment with all newest version of applications. So it was very very convenient for developers to test on every build or even commit. But to leave this approval gate for someone who will take under consideration test results and some other factors. Last thing about this release pipeline was that alongside with container images, we also released something that we called and created from scratch release manifest that described a whole release. We also archived them with OpenShift templates and some scripts into Artifactory. So it enabled us to test some application that was released a couple of months ago, because templates were also changing, and scripts were also changing, and they were archived because they were part of tests. So we knew that they were used to create environment, because I forgot to mention that this release environment, the release namespace, was created from scratch whenever a new deployment process was started. Okay, so what we what we managed to do is not to. This is actually a sample screenshot of release pipeline, but the deployment itself, our goal to have 10 minutes released was achieved. So at least a couple of months ago, I'm not sure how does it look right now, but we managed to leverage containers to achieve this 10 minutes, and actually we did it in 5. So we managed to deploy, to shorten the whole process to 5 minutes. And Now David will tell you something more about how to create a secure container images. David, get back. I'm giving you the floor. You're muted, I guess.
Sorry. Right.
Yeah.
Thank you. Thank you, Tomek. Well, I will now tell you a few more words about the creating secure container images. What was the path we have chosen here in the bank and how we're doing this. There will be a few more technical details on how we have achieved this. So first is, as you probably know, most of the people using Docker technologies are using Docker Hub, right? So they're fetching the images from the Docker Hub, making some, I don't know, modifications, let's say. So using the Docker Hub image as a base and then doing something more. Unfortunately, because Docker Hub is not a best and secure way to use these images because there is a lot of different tweaks in a bank infrastructure that need to be taken into consideration when using an image. So shortly, I will now tell you a few about, but there were a few decisions we have taken. First is use GitHub to fork clone image sources. So we are not using Docker Hub images. We, of course, because we want to be part of the open source community, we are cloning the sources, so the Docker files of the images, and sometimes even some sources of the code, and then we are preparing our own images for this. Why? Because one of the advantages of having the OpenShift and CloudForms integrated is to have the built-in mechanism for security scanning. But this mechanism has one limitation. It needs to be, all of the images that are run on the platform need to be Red Hat Enterprise Linux based. So because we are the Red Hat customers, we have the Red Hat Linux, a lot of Red Hat Linux in our organization. It was straightforward for us to use the Red Hat as a base image. And thanks to that, we got the scanning possibilities of the CloudForms also, which is a part of the OpenShift. So these were the first decision. As stated before, we are using sources, not binaries, so no Docker Hub. We have our own proxies and repositories, our own GitHub, our GitLab. We are using GitLab internally, our own instance. We have a proxies to, I don't know, proxies for the build artifacts for the Maven repositories, etc. We have a lot of proxies for this, and very often, let's say, the source to images that are on even on Docker Hub sometimes are not supporting this proxies. So we are creating our own images for as the source to image for the OpenShift. We are using this also. We are using our own images because we have our internal certificate authority as a bank. So we have a lot of encryption endpoints in a bank. For each of these endpoints, we need our own certificates. These certificates are not signed by, I don't know, Taft or anything, so by any public CA. Why? Shortly, because it's really very expensive and really not needed inside the organization, but it has the consequence because almost all images which are available on, let's say, Docker Hub, on either in the Red Hat repository, let's say Red Hat Docker Hub, because there is something like this also, do not support using your own CA, which is not publicly trusted. So this was one of the limitations we had to handle with this. We have our all services protected by TLS. This is also something I mentioned before. And once again, Docker Hub images, not all of them support them. And to be honest, almost none of them support this out of the box. So we need to make changes in these images. We need to provide a boilerplate for developers. So when we have our own base image, the developer need to focus only on his I don't know, Java code or Angular code. He don't need to think about, okay, how to run this. how to create a Docker file for this, because we are using our own source to image. He don't need to look in the internet for the runtime environment for his application. And because of that, because we have our own images, so at first we have our base Red Hat image, then based on this Red Hat image, we have Red Hat Enterprise Linux image, which has, let's say, our certificates. We have Java and JavaScript images. When we need to make a change, we, for the most of the time, make a change in only one place, right? So when we will change our certificates because they will expire, let's say, then we will change it only in one place, in one image. Okay, we need to have the cascade rebuilding of the all of the others, but it will be easy to change. If we will use the Docker Hub images or even Red Hat images, then we will always need to make another image on top of these images, and then such changes will need to be done in almost every image we are using. So for me, it was one of the hardest thing to consider and to decide how to build applications based on Docker on the OpenShift, how to create the base images, and how to handle all of these differences between financial institution, a bank, and a typical company, which really, I think so. You may be thinking different, of course, but you won't almost anywhere have these troubles, because, for example, as a bank, we need to use our internal Git. We are not able to use the github.com or gitlab.com, and the public services are signed by the public certificates, while our internal Git is signed by our private certificate. So our image need to handle this, right? So there's a lot of such issues. And here, just really the simplest example what we are doing. So we are a simple example of the Docker file. We have the from registry access redhat.com. This is this Red Hat Docker Hub I was telling you about. We are getting the rel 7 latest, then we are changing the time zone. Oh, there's even a mistake. I will need to verify our Git. It's not valid, I see, because the symlink is not valid for Warsaw.
Yeah,
I will
maybe
verify.
yeah,
Yeah,
maybe
it can be a typo in
we made it
presentation.
during. Yeah. Don't just
Okay,
copy and paste into your production Docker files.
but but the best thing is that even if it's a mistake, I will be able to fix it in just one place. So it will be
Yeah.
awesome. So you can see there is fetching the CA1 CRT from our public website with our public PKI. That's our internal PKI. Update CA Trust Extract, and the operating system itself already has the banked certificates, and then on top of this we are building another images. So I think this was the part of how we are building the another decision we had to take to being able to create secure applications on this really base level, because I'm not talking about the development itself, but about the same base level for runtime environment for the application. And then, as far as I remember, Tomek will go forward with another point. Yeah, I think.
Yeah. So let me tell you something about old world and new world when it comes to compliance. So containers are something new. We agree on that, and many procedures that are currently used in many institutions, not only financial institutions, are applicable to this old world. And by old world, I mean like world built from virtual machines, from servers that you can log into using SSH. And we knew that this is something new, and this is something new also for security departments. And when we had many discussions with security team, we told them about some different things that different approach for example, IP addresses, because containers have dynamic IP addresses, and there are many new things that are created dynamically that are not that are given unique IDs, not some known names. It's just like pets versus cattle approach. So we had discussions and we introduced and we recommended a new way for dealing with security on OpenShift, and the new way can be called as security in code. So we had discussion on how to use, how to switch from old procedures, because we were given we were given procedures that were applicable to some Red Hat Enterprise Linux, and actually we were deploying some containers that didn't have SSH, for example. So we thought that it's a good idea to start talking about things like keeping them as scripts rather than documents, and using automations tool like InSpec, for example, to keep your security compliance within a code, within a versioned repository. And we also faced as far as I remember, it was some time ago. It was February. It was February the 2nd, as I remember, when we got security scanning report, and there were many issues there. So we weren't happy. Let me tell you that. And fortunately,
Neither
some
we.
of the yeah, sorry, but yeah, we were working on OpenShift, and that was before bank decided to go. Well, the security scanning test was because of why bank has decided to go with OpenShift, and they wanted to just check the platform. And yeah, there was some misconfiguration. We recommended a way to fix them. Some of them were fixed in next version of OpenShift, like for example, changing type of algorithm used for securing traffic. And but what was interesting is that we found many duplicates, and it quickly turned out that those duplicates came from the fact that we used OpenShift router to secure all traffic to applications. So we exposed only HTTPS interface, no plain text traffic using HTTP. And there was some misconfiguration in OpenShift router regarding HSTS configuration. And fortunately, it was a matter of minutes a way to fix it. So and we quickly realized how easy it is on OpenShift, because if we got this similar security scanning reports for this old world approach, we would have to change HTTPS or change HTTPS setting on each application separately. And imagine a scenario where you need to, for example, change all SSL certificates for your apps. So using OpenShift router is just a matter of changing it in a single place. And in traditional old world configuration or changing anything on this very important when it comes to security layer is just hard. So now something about traffic isolation, and I know David has something to tell you more about it before I go with my part.
Yeah, exactly. As I stated before, when we were wondering how about our cluster design, how many clusters we want, we need to make a separation for the DMZ and the internal cluster. And then after this separation, we also realized by consultations with our security colleagues that even this separation for a bank is not enough, because inside the demilitarized zone, you need to control traffic incoming and outgoing between the application. And this was the time when the OpenShift was not able, on the version 3.6, was not able to realize this requirement. So it was it was not easy with technology. And now I think Tomek will tell you a few words about how we were able to prepare for this with the newest version of the OpenShift.
Yeah. So basically, if you're not a startup, if you don't have a single project and have many projects or even many clusters like BZWBK have, you want to be able to separate, well, to filter your traffic, especially outbound traffic, and that's part you need to be aware of, that you can control outgoing traffic using egress network policy, for example, in OpenShift. But additionally, there's a traditional static firewall that comes from this old world that you still need to take care of. So it's not only about rules for OpenShift for traffic inside OpenShift and outgoing on OpenShift, but also about this part that needs to be taken care of in a traditional manner. Of course, you want to have control over inbound traffic. That's obvious, I guess, if you have multiple applications, multi-tenancy environment. But can you do both? Obviously, you should. But as David mentioned, in OpenShift versions lower than 3.9, it wasn't possible, and that was really it was a sad information. So we couldn't we couldn't we couldn't provide such solution on OpenShift 3.6 using, for example, egress network policy or network policy, because they couldn't work together. So we decided that we needed to at least isolate projects, and we turned on a default project isolation. But we also come up with something that is very, very complex and cumbersome to implement. So we wanted to provide a bank with a solution that would leverage existing solutions using egress network policy and some access lists on routes. Fortunately, when we found out that OpenShift 3.9 will provide network policy, we abandoned this project because it would be hard to maintain. And yes, and finally, from OpenShift 3.9, we have network policy, and this is really huge advantage, and this is a feature that makes OpenShift enterprise ready. This is our opinion. This makes OpenShift solution enterprise ready, because you are now able to filter traffic between projects or environments inside OpenShift cluster based on very flexible things like pod labels, not IP addresses, based on project labels, not even names. This is very convenient. And of course, if you want to go to communicate with some external external part, outside of your OpenShift cluster, you can, of course, use traditional IP addresses, and always be aware that there's a traditional static firewall that probably there's somewhere out there that is configured by your network administrators. So,
and one, if I can, and one important thing, thanks to this functionality, currently, even the sprint is ongoing right now, I think, we are considering implementation of this. We are making the tests at the moment of this functionality, and if we will succeed, and I believe we will, then we will have only two clusters, one production and one test, because thanks to this functionality, we will not have to separate the LAN cluster and DMZ, because thanks to the full filtering, we just are able to make fulfill requirements of our security. So this is something that was not on the one of the first slides, but now it can be done.
Yeah. So actually, what we managed to present here today was part of something that is described in more details in Red Hat white paper. So we provided some more information regarding container registry, pipelines, and so on. And if you are interested, you may find this document useful. And I guess, David.
Yeah, and shortly, for a short summary for the end, this is, sorry. And shortly, this is something what we are calling DevOps in a bank. So we were not using any buzzwords during the presentation, but this is a project with the partner Mindbox that allowed us to make a really big change in our company for how we are creating applications, how we think about the application, how we deliver them, and how even developers create the applications. So this is something we want to share with you and tell you a few things about it. So thank you, and I think Patrick will now take.
I have only one more thing. So actually, if someone is interested in topic on how to create a process for auto patching your application containers, just let me know. Just drop me an email, and I might have a solution for you, which is OpenShift native. You cannot achieve it on Kubernetes. So if you're interested, just drop me an email. So thanks, and I guess we'll get back to Patrick. Patrick.
Thank you, Tomasz and David, for a great presentation, for hosting this great webinar. A lot of nice technical content, which I think that our audience can benefit of and really enjoyed. So that we have a couple of questions on the chat, which I will address them in the timely order. Okay, if we agree, we have approximately, I guess, 11 questions in general. So because we are already running this webinar for 1 hour, I would kindly ask you to just try to answer as quickly as possible. Okay. So let me start with the first question. Please decide both who wants to address the question. So okay. First question from Łukasz. What kind of storage did you use for internal registry? What about replication and access control?
I just want to answer very quickly on this because at first we were using Artifactory, and Artifactory was managed by some dedicated team, and then bank decided to switch to internal. I'm not sure, David, what is the storage underneath this internal. So I'm not sure if I can answer this fully.
To be honest, I'm not sure at the moment, but as far as I remember, because we have the storage for storage for the internal Docker registry. Unfortunately, this is something we have also realized during the project, that we are not ready for such platform on the storage level, because what is heard on many presentations throughout the world, that when Docker, the containerization appeared, then the network file system has its second life. And to be honest, yes, we are using NFS for this at the moment. We are working on something like Ceph or Gluster, but this is not yet ready.
Yeah, so Gluster, I guess Gluster is a recommended solution also by Red Hat. So this is a replicated storage that can be used as well. Okay.
Okay, so next question. How do you accomplish full CI/CD pipeline, go from CI to CD in automated way, where in CI is focused on single component and you said your CD is based on set of components?
Yes, so probably I can answer the question. When we were building it, we made a separate CI pipeline. This release pipeline is actually a part of CI, and most of the tests are done there in CI part. So application itself can do some dedicated CI tests, like unit tests, integral tests, only for this particular application. And then in this release pipeline, there are tests. I'm not a tester, so sorry. Probably. So maybe I'm naming it wrong, but they were something similar to end-to-end tests. So they were testing in this release pipeline. There were tests for checking actually whether these applications can work together. And after that, they were published, and then they were part of continuous deployment pipeline, where there are only some simple smoke tests, as far as I remember. But I'm not a part of release management team in Bank, so maybe this is something that has changed and hopefully evolved, because Bank has been improving it since then.
Okay, next question. You said that the whole release takes about 5 minutes. What about test? It has to be a really basic test if it takes less than 5 minutes.
I guess I answered that when talking about when answering the previous one, because let me just repeat it. There is a dedicated pipeline for testing applications, whether they can be released to further to next environments. And actually, containers give you this leverage that if you test them, they are ephemeral. They cannot be changed, and only configuration can be changed. So only parameters can change from environment to environment, but not application. Application after release pipeline was put in a container registry, and then is ready to be used in next environment.
Okay, and also you said that during creating a version, you are building an app. Your screen from Jenkins didn't reflect this. Can you explain how did you manage CI?
Version of an application is actually something that we called release manifest, where we stored metadata for container, metadata with basically info info on container versions, container images versions. So a container registry gets its tag, so it's being tagged by Jenkins, pushed to a container registry, and additionally this tag is put into a release manifest that actually is an artifact, and it's also put into Artifactory. So this is it is a little bit complex, but that was a requirement of release management team to have this not release process of a single microservice, but a release process of an application that consists of multiple microservices.
Okay, next question from Marcin. By having one cluster per environment, how you're not worried about global cluster outages? How about disaster recovery, data center redundancy? Are you keeping there some non-critical front-end services rather than core components?
Okay, I think I will address this one.
Yeah.
Well, there was really a lot of discussion on the beginning of the project and even in the middle of the project, how to implement this, how to do it correctly, and how to do it as effortless as possible. And what we have decided is that a bank has its two main data centers, which are geographically separated in the way that they also realize disaster recovery. So what we have done, I was talking about that we have, let's say, the minimalist version. We have a production cluster and test clusters, test clusters, sorry, but they are the part of the components is in one data center and the part of the components is another data center. So one cluster is not in one geographical localization, right? It's in two different localizations, and resources are created this way, provided this way, that in case of the half of the cluster, so one of the localizations will become unavailable, then the another half will handle the whole traffic on it. So it's it's something who was not mentioned in the presentation, but there was really hours of talk about it.
Got it. Thank you. Question from Katarzyna. What about databases? Do you integrate your containerized apps with some traditional database, use attached volumes?
It's me again.
Yeah.
Okay, so well, we have made some mistakes on the beginning to put some databases on the OpenShift, but as stated a few minutes ago, we are not yet ready with, let's say, 2018 storage available in the methods of accessing the storage. Please remember that we are not able to use cloud solutions, so we are not able to use anything that is outside our infrastructure because of the Polish regulator. I won't go into details, but we are limited by not using cloud, so we need to have all of the functionalities on premise. So shortly, currently our requirements for applications states that when you want to provide a new application to the bank and when you want to go to the OpenShift, you need to make sorry, I need a word. You need to mark your application as application that is totally stateless, and then you can go OpenShift, no problem. Application which requires state, but only on the level of the cache. So you can also go to the OpenShift with such application, but only if you will create this application in a way that when the cache is not available, the application will not show error to the user. So it will work, it may be limited, but it will not show an error to the user. And the third type of application is application which requires a persistent storage, like databases, and they should be outside the cluster. So currently, only stateless applications are there.
Okay, thank you. The next question, it's hard for me to get from this question who should be the recipient of it. How large was the team which worked with you? So it may be,
okay.
understood in a different way.
It depends on definition of a team, I guess. So I guess we were a team, but I'm not sure.
So how big
with you work in terms of on present situation, because
on
bank
the project,
has many on the project maybe. It wasn't big, I guess, but it was very. We work like commandos, I guess. So we were focused on this single task. We had many.
Let me answer the question. I can tell you, I can give you one number. It was less than 10 people working on this. Of course, we were using, I would say, external services, like someone providing us a network, someone providing us storage even that was mentioned, someone providing us machines, etc., etc. But I can tell you that the team was less than 10 people, and that's why maybe if you will take a whole picture of this project, you can sometimes maybe say, oh, but it's incomplete, they don't have something like this, etc., etc. But you also need to remember that we had the business project on the top of us, which required us to provide the platform that is running, etc., etc. So from my perspective, as a person which is working a long time in a bank, it was a project that was possible to be made by such small amount of people only because we have changed the way we were working. So it was less than 10 people, but I think we have managed this. Sorry.
Okay, great, thank you. Question from Michał. How you explore images vulnerabilities?
Well, we are using CloudForms, which is watching our cluster, watching our images that are deployed. We even somewhere on the beginning of the project had an issue when just yesterday everything was working on the cluster, and we came in the morning and nothing wants to deploy on the cluster. Then we were making a lot of debugging what's going on, and then we have found out that the CloudForm is marking our images as insecure, and then OpenShift didn't want to deploy them. And so we had make some tweaks to this policy, but it is protected, it is verified by the external platform like CloudForms, which is also a part of the OpenShift product.
Yeah. Got it. So a question from Jack. I don't know the context of it, but well, I'll address it if we're talking about the Red Hat product. So why you don't use Ansible and Ansible Tower? As I said, I don't know the context of the question, whether it refers to the implementation.
I think it may be a question related to some of the first slides showing that, okay, we had a virtual machine, we have the virtual machines, but there are a lot of problems because it's a lot of manual work. So please keep in mind that this presentation is focused on the OpenShift, and the point was to show how we are changing from one way of the infrastructure, how IT works to another way. And I was not mentioning this because it's not the part of the OpenShift project, but in parallel, we also had a project to automate let me use the word legacy infrastructure. And yes, we are using tools like Red Hat Ansible, like Ansible Tower, like Chef, etc., etc. So we are using another tools to handle this legacy IT.
Got it. Thank you. Next question from Gary. So I think we already addressed the question about how many people work in the project from this very beginning, but there's another part to it. Is there only one team that is involved in OpenShift platform and building CI/CDs?
So maybe let me answer this yet. We were one team during the project, which was composed of people from different, I would say, permanent teams. So we had guys from Mindbox that were supporting us. We had guys from the system administration, from infrastructure, and the developers. So we have created I don't like the buzzwords, but we have created a DevOps team, which was handling the whole solution. Sorry, agile, yeah,
Agile.
yeah, agile stroke DevOps stroke other buzzwords team. So yes, currently it's a little bit different because the platform itself is managed by infrastructure team dedicated for this. They also manage the framework for the CI/CD, and each of the agile teams that is creating his own application, their own application on the OpenShift, are providing, let's say, data for the framework to get the CI/CD working. So I hope it answers your question, Gary.
Okay, question from Daniel. Are there some new interesting functions in version 3.10 of OpenShift that you would utilize as well for your project?
I guess guys are working on 3.9.
Yes, I wanted to pass this question to you, Tomek, because the only thing I remember that I came to work in the morning and I saw an email. Okay, guys, now we are on 3.9 on our clusters. We've made a migration. And then I opened my browser and saw, oh, there is 3.10 released yesterday. So I sent an email to guys. So when you are going to migrate, but for as far as I remember, Tomek, please confirm. But 3.10 does not provide some really big,
No.
it's not a big changer.
No. 3.9 was a big and very necessary change because of those network policies. 3.10. Personally, I wait for Istio to be in a production to be supported in production OpenShift, and maybe for Prometheus to be also supported, because currently Prometheus is in tech preview. But there is not major things in 3.10. Of course, this is something that you should install when starting your new OpenShift cluster. But 3.9 was a major thing because of those network policies.
Okay, last two questions. So any problems with PCI DSS certification encountered during implementation of this project?
Very good question. To be honest, we haven't yet found out any application that needs to be covered by PCI DSS certification on our platform. So I'm not able to answer directly to this question. But on the other hand, because we have a specialist in our organization from the PCI DSS, and also because as a bank we also have the PCI CP card production certification. We are also a card producer. I believe because this person was involved in project and was also challenging us with the security, I believe the cluster will be compliant, but we have not yet touched the topic, as I said, because there is no business application that requires PCI DSS on the cluster. But it may change tomorrow. I don't know. Sorry, no more detailed answer.
It's moving very, very fast. Yeah.
Yes.
Okay. So another question, have you had any problems using OpenShift Ansible in production environment? Any limitation on root logins or sudo commands like no exec setting?
Okay, Tomek, maybe you.
So we have our expert who is not here with us, who performed dozens of installation. So Bartek, he's not here with us today, and he would have a better answer. But yeah, so OpenShift Ansible, so basically the project is very universal. So you can do almost all of the things from OpenShift Ansible, but as David mentioned, it doesn't support IPSec, for example. So that's why David and his team had problems when upgrading OpenShift. But I guess it's getting better and better. I've used it also many times. Actually, I found a very interesting project around it, which is available on GitHub, which is Red Hat Community of Practice, and there are many additional things that if you're interested, you may find useful. There are many things that aren't involved in OpenShift Ansible project itself. But it's getting better. It's not perfect, but it's, first of all, in version 3.7, it got better because they introduced a modularity approach when you can install only a particular version. Before that, in 3.6, you had a single monolith-like playbook. So.
What I can tell you in this topic is that okay, I was not and I am not directly involved in the upgrades currently because the dedicated team is handling this. But the only issues I've heard from them that were big enough to escalate were the issues with the IPSec. So yes, I know there were issues, but they were solved during the upgrades. And the only that was escalated from the team was, guys, we need to take care of this IPSec because it's really pain. And this was escalated and this was solved. And no other issue big enough to have some bigger problems was identified, at least by me. So I think it's improving.
Okay. And the last question, are you using blue-green deployments in OpenShift for upgrades of OpenShift or OS updates? Any tips on automating this? How are you automating adding and removing ATCD nodes?
Okay, so I won't be able again answer directly these questions because I'm not involved in the upgrades itself. But what I can tell you is that we have also, when we have started our project, we believed that the bare metal is the best solution for the Dockers. And well, we have built our clusters on the bare metal. Few very big machines, which are usually used as the bare metal under VMware. So they were really big machines. And because of the issues with what you asked for, so Brooklyn deployments, upgrades of the nodes, etcd, etc., our team decided that we are going to the smaller nodes based shortly on the VMware in our infrastructure. So this is only thing I can tell you, that from the really big machines we have migrated to we are now during the process of the migration to the far much more smallest machines. And the main issue was to improve upgrades, to make them easier and to not disable, let's say, I don't know, 1/8 of our cluster just by removing the machine. So this is something we have also identified and managed in a way that we are changing how nodes are, how big the nodes are, and by what technology they are provided.
Okay, gentlemen. So thank you very much for your great presentation. Any last words you would like to cover today?
Well, thanks for joining. Thanks for spending time with us. I guess it was fun, and it was a great pleasure to present you with what we've done. And thanks, David, for his cooperation. He was a very good member and very precious member of the team. So thanks a lot.
Yeah, I would also like to thank you guys, everyone on the. There is maybe some short question. Thanks, Łukasz. Also, thank you guys for keeping so long with us. I see the number of people, and I see how this number of people was changing during our presentation, and it's really great information to see that this number was almost stable for the whole time. So thank you very much for being here with us.
Yes, thank you all. Thank you for joining the webinar. I hope you had a great value of it. So join us for the next webinar. We'll be informing you the standard way. And I wish you all a great day. Thank you, Tomasz, David, for having this webinar with us. And good luck with another projects. Thank you all.
Thanks.
Goodbye.
Thanks. Bye.
Bye.